All right, everyone. Welcome to Class 5 of the Cloud Solutions and API class. This class is Advanced API Integrations for Data Science. And I am your instructor, Jeremy Bergman, for Omaha Data Science Academy. Okay. So how this class is structured is just slightly different than the other classes. The first hour, we're going to cover the Microsoft Azure topic first. We usually cover the new storage or compute overview first, the new concept first. But in this class, we'll cover Synapse Analytics first because, like I just said off camera, it's really like within Azure, like a centralized, integrated data engineering platform that contains storage and compute and machine learning and analytics and data warehousing. It's like the entire package or integrated development environment for data engineers. So it brings everything that we've learned in class together into one platform, and we'll use this platform the rest of this class. In hour 2, we will take a look at automating data collection using APIs, data pipelines, and Python notebooks. So this is where we take what we learned in class 1, and then we start utilizing Azure Data Factory and visual tools and code and data pipelines to be able to start automating that data collection. That is huge within data science because the more you can automate, or just business intelligence or data science in general, the more you can automate and don't have to do manual collection, is that much more time you will save. Plus, it tends to be higher quality the less you have to manually touch or transfer or transform data. So it helps with that, and a lot even when you're talking about machine learning or analytics, being able to get data in near real time is a requirement for some of those types of models. So being able to now collect data in APIs, automate those pipelines, and capture that data is huge for those type of models from a data engineering perspective. So we'll learn hour 2 how to implement that. And then hour 3, we have another hands-on exercise. We're going to create that data factory pipeline within Synapse Analytics to connect the data lake and MySQL. I should say, instead of the crypto CSV files, we will use a REST API where we can get the data, where we can get crypto data from. It was in those CSV files, and now we can go out to the crypto API and start to automate that data feed. So that's what we will work on today for our hands-on exercise, is implementing the entire workflow and integrating API into it. The class 5 objectives, we are going to do like a full overview of Azure Synapse Analytics. We're going to take a look at it as a whole and integrated platform and its components. Then we'll take a deeper dive into a couple of these topics. So Synapse Studio, it's what I call a data engineering IDE. So you may have heard the term IDE in your Python class. If you use something like, I just call Microsoft Visual Studio an IDE. When I use Python, when I use Anaconda Python, I use what's the name of that IDE? I can't think of it off the top of my head, but it's an integrated development environment that gives you a bunch of tools to help you with your development of whatever pipeline or code that you're creating. So like Visual Studio would help you with a bunch of integrated libraries. It gives you an environment to run and test your code, to monitor it. And Azure Synapse Analytics is that for data engineering. And it contains all of these tools within this integrated integrated development environment to help the data engineer. So it has pretty close to most of the tools or all of the tools that you can use. Either that or it's a highly integrated platform. So it's integrated with things like Cosmos DB or other software outside of it. So it's highly integrated with the things that it's either within Synapse Studio or maybe just outside of it. We'll take a little bit deeper dive on SQL Server pools. There are two types of server pools within Azure Synapse Analytics. There's serverless and dedicated. Dedicated is more of like the one that you think of with a regular database instance, a managed database instance that you could create like MySQL or Azure SQL Server. But it's a little bit different in Azure Synapse Analytics because this is a high performance SQL database that's dedicated for data warehousing. And it can be turned on and off quickly to be able to save you money and computing power. Serverless is a really like a interesting feature. So this is like an on-demand SQL pool. And this is one that is just turned on and off based on your needs, query needs. And what Synapse Analytics does is allow you to not only query, it not only allows you to query SQL databases, but it also allows you to write SQL code for files inside of the data lake. And we'll see this in action, but basically it's an extension of SQL that's really powerful for any type of tabular data that lives inside of the data lake, whether that's CSV files, Excel files, some of the proprietary formats like Parquet, or whatever other tabular formats there might be, CSV files. I think I already said that. But we'll see that in action. We'll dive a little bit deeper into that because it's a powerful tool. We'll do that with the example that we created. And then Azure also has Spark pools. This is for bigger data analytics type workloads. So you're able to have distributed computing within Spark. And then you're also able to use PySpark, which is Python within Spark. I have an example of where we create a data frame. So we'll take a closer look at that also. Then finally, the last part of the class, will be automating data collection using APIs. So I'll talk about the importance, benefits, and real-life applications. And then using Synapse Analytics, Azure Data Factory type pipelines to be able to automate data collection using APIs, and specifically in this case, using REST API from the crypto data site. I can't think of the name of the website right now, but I'll refer to it as a crypto website. And they have a series of REST APIs where you can get up-to-date information about various cryptocurrencies, volumes, and like stock-related type information, price and volumes. Yeah. Right. So what is Azure Synapse Analytics? We started to cover this last Wednesday when we talked about compute, say data processing and computing power. The last lecture number 4, that wasn't quite the name of it. Give me just 1 second to recall the name of it. So data processing in the cloud, yep. So we covered this as part of like, one of the ways that have data processing in the cloud. The thing about Azure Synapse Analytics is that it contains computing in the cloud, such as contains Apache Spark, and then it has SQL databases for the compute also. But it's really, and SQL Server or serverless on-demand SQL pools that you can create. So it does have compute, but it's more of like an all-in-one platform that includes more than that. So I talked about the integrated development environment. It integrates data lake, storage. It's highly integrated with Azure Gen 2 storage. When you set up Synapse Analytics, you actually can set up a data lake along with it. That's an integrated data lake. It has data warehousing. So for those databases that are usually these will be like the ones that you make that are more permanent. You could create OLAP relational data structure, and then you have some tools like Azure Purview. So that would be like your data quality and your data dictionary and things like that. So it includes tools for data warehousing, more analytical processing. So this is the part that we covered in class 4. Includes data analytics, so it's highly integrated with Azure machine learning, which we'll learn more about in our next class. And then Power BI. Power BI is now fully integrated into Synapse Analytics. Usually that's a more recent thing, but it brings a lot more leverage and power to Power BI to have it an integrated part of Synapse Analytics. Makes it much easier to deliver data and machine learning and artificial intelligence and information dashboards and so forth out of the platform. Data processing has more. It also includes its own version of Azure Data Factory, Data Explorer, and data flows. We didn't cover data flows very much as an activity when we covered Azure Data Factory, but data flows are a series of transformations that you can do on the data as an activity in a pipeline. So maybe you have some cleaning to do of the data or transformation of the data. Data flows inside of there allow you to do that. And it has some highly integrated data flows, and also has Power Pivot also that can help you pivot data or summarize data and so forth. And then Azure Synapse Analytics, one of the big positives is that it's built for collaborations, especially between data scientists and data engineers. So one of the things that Synapse Analytics has is they have Jupyter style notebooks, which I asked everybody in the second class, and everybody's familiar with Jupyter notebooks. But what you can do in Synapse Analytics is save your Jupyter notebooks as code, and then easily be able to share that code between data scientists and data engineers. It also has data warehousing, which builds collaboration for end users also. So it builds ways for data scientists to be able to collaborate with data engineers, who then can both in turn collaborate with other data analysts and their end users. So it's meant to be where you can share and collaborate on data. So a lot built into Synapse Analytics as a totally integrated all-in-one platform for analytics projects. So continue. So the features of Synapse Analytics. So as we said a few times, highly integrated, has big data and data warehousing included in a single service. We'll call Azure Synapse Analytics its own service, its own resource, and its own service within Azure. It includes visualization and data analysis. So that part of it, the integrated analytics, the big data and the data warehousing, is the Apache Spark pools and the provision SQL and provision SQL, like more like the data warehouse, and the SQL on-demand pools where you can use a variant of SQL to be able to query things within the data lake. So it also contains data integration. So ingest, it uses Azure Data Factory pipelines and the mapping data flows that we talked about. On-demand query processing. So data warehousing and query capabilities with serverless pools. So this is purely on demand. It's only when you need it, and you're only charged for queries that you use the computing power on. So that's actually can be an advantage because if you're running a database, you may have to have it on all the time or in the cloud instead of having a database that's on all the time that isn't doing anything and is just using up computing power or disk space or whatever. The on-demand pool is only on whenever you run a query, so it can reduce the cost of your analytical computing. Apache Spark integration, so it's highly integrated with Apache Spark, allows you to perform big data analytics, facilitates a seamless combination of data integration, ETL, Python, and machine learning tasks. So usually I do a lot of the data integration, ETL within Data Factory, but this is really helpful if you already have ETL that's created in Python. So say you have Python code that extracts, it's custom code that extracts data from a system and already does all the transformations. This Apache Spark may be the perfect place for it. You can just put it in a notebook, include it in a Azure Data Factory workflow, and then you're off instead of having to recreate like some code within a pipeline. It also includes its own machine learning libraries. There's the Spark ML libraries. I haven't used them personally, but they're included. I usually would use the machine learning lab in Azure because it's a visual editor that you can create models with and then produces your code and everything at the end. But a lot of people do leverage machine learning and Spark because of the computing power, how you can scale up and down for machine learning tasks. And then some data integration that you can do with it also. Management tools, so it's a unified environment for managing and monitoring all of your data and its related processes. So much like Data Factory, it includes monitoring and management and security. And then also includes, can't see the bottom of that very well. So built-in data exploration tools such as Power BI and like we used at the beginning of class, Data Explorer. Developer tools. Languages such as SQL, Python, Scala, and Git for version control. So a number of developer tools are also included inside.
Hey, Jeremy.
Yep.
I just saw that Missy got kicked out of the room.
Oh, no.
Is she back in yet?
Let's see. Thanks for the heads up. I was just got my head wrapped around the lectures and didn't check. Let's see. Okay, there's StreamYard. We'll add her back to the stage, I think. Hey, welcome back.
Jeremy.
Could you listen, or were you able to hear while you're off stage? Or
Yep, I could hear everything.
yeah, I think that you can still hear everything. Like you can have so many people on stage. That's like a way of like being like one of the contributors potentially. Like you could like pass the microphone to, but I think if you're off stage, you can still hear. But we'll go ahead and include you here on stage.
Thank you.
You're welcome. So yeah, just finishing up the Azure Synapse Analytics features. Yeah, and then storage. It's in Azure Synapse Analytics. One thing I don't have here is the storage. You have your regular relational databases that are integrated. So MySQL or Microsoft SQL Server, Gen 2 data lake, Spark tables, and Cosmos. So I think this covers actually largely the vast majority of what we've covered in the class up to this point. The it doesn't directly have all those different NoSQL databases, but it is highly integrated with Cosmos DB. So that's why I moved this lecture forward a little bit, because we could focus on Azure Synapse Analytics and basically have all of the tools that we needed for the rest of this class to be able to do our data engineering all in one integrated environment. So then the rest of the class after this, we'll do machine learning, and then we'll focus on big data before we take our final exam and do our project. All right. So Synapse Studio IDE. So Synapse Studio is really a unified web-based user interface of Azure Synapse Analytics, and it serves as a central hub where users can manage and monitor all aspects of their data solution. Synapse Studio users can create and run SQL scripts for, there are actually a couple different types of variants of SQL scripts that you can do in Synapse. You can do regular SQL scripts on your managed SQL databases. You can use T-SQL to query the data lake. And then there's also a version of SQL that you can use inside of what can I think of the name? Apache Spark. You can use SQL within Apache Spark to be able to query those. So there's a lot of like SQL-like variants, and a lot of people are familiar with the SQL language, which really makes it easy to get around tabular data. Integrating and analyzing data using notebooks. So within development, you can create new Jupyter notebooks, and those are the ones that you could use along. You can share with other people and use PySpark, so Spark for Python, be able to create those notebooks and integrate them into workflows. You can build, manage, and monitor jobs, so you can build jobs or pipelines using the integrate functionality. You can set up SQL and Spark pools, data flows, etc., and then be able to monitor and manage pipelines. So performance and failures or successes of the pipelines. Of course, you can design data pipelines using Azure Data Factory, like pipelines utility in here. And then you could access built-in data exploration tools such as Power BI and Data Explorer. So it's integrated all in one environment. I'll go ahead and show everyone this in my web browser real quick. Go ahead and bring this up. So if we go to the Synapse Analytics workspace, or we go to the resource group first, it'll be getting started to open Synapse Studio. Of course, Microsoft's always good about having lots of documentation. Then some information down below of the SQL pools and Apache Spark pools that you have set up. That you've set up within Azure Synapse Analytics. And to be able to engineer everything, you can do this right in your web browser from this platform. once it finishes loading. Take just a second. Right, you can see you land here on the workspace. You can create new scripts, notebook, data flows, Apache Spark jobs and pipelines. You can ingest data. You can explore and analyze using Data Explorer. You can visualize using Power BI. And then you can see some of the recent files that you're used. But over here on the left side, you can always go back home to this screen. Your data is to set up workspaces or your SQL databases, your data lakes, or your Data Explorer, and then you can set up your link services here also like you do in Azure Data Factory. So fairly similar to Azure Data Factory. Also, there's a Develop tab where you can do SQL scripts and notebooks. You can do a couple of different types of scripts. I forgot exactly what the KQL script is. I'll take a look at that and let everyone know at break. But a couple different scripts to create a data flow for data or Spark job. And then you can create your data pipelines within Integrate. You can create the connections. You can use copy data tool and pipelines. You can monitor all your jobs and your different pools and the performance, your activities. These will even show you what queries you've run on the data, how long it took and how much data you processed. And then your pipeline runs that you have. So I ran a pipeline that was successful and anything that was triggered. So you're able to monitor the execution of everything and then be able to manage your resources also. So really highly integrated environment. I believe this is where you can take a look at your SQL pools, like Apache Spark pool. And you could get information and even edit the resources in it. So if you wanted to scale up, you could click on a button, and then there's all your information to be able to scale up an estimated cost. So really everything, as a data engineer, it's really nice to not have these all in different places or have to manage Spark separately or having to manage a server with or even different pieces of software, the number of pieces of different software to do the same thing. Since it's all integrated, it's like really easy to use in conjunction with each other, which makes each piece even more powerful and valuable than before. So data engineers, you could live in this thing as a data engineer. I'd say for sure. Very nice IDE for data engineering. And that includes almost all the tools that you'll need. And probably 90% of the tools that you need, and some things you could use outside of it. Okay. So Synapse SQL pools. We'll have a video here in a second because I'll show everyone how the on-demand queries work. A short video. But Synapse SQL is a core component that allows you to run SQL queries across your data. It has two distinct functionalities. We started to talk about this, but this will put a little more detail into this. So we're starting to go into a deeper dive on a couple of the components that we're less familiar with, but are really pretty strong features of Synapse Analytics. So on-demand queries are your serverless SQL pool. Allows you to query data as needed without provisioning resources in advance. You can query data directly from data lakes in the various formats like CSV, Parquet, or JSON. So, forgot about the JSON part, but what will happen is that the interpreter will try to flatten out the JSON file, and you can start to use it like it's a flat table or query it like that. So super powerful in being able to query structured data or even semi-structured data. So your data is dedicated SQL pools. This is more of like your data warehouse, and it's like your regular provisioned MySQL or MS SQL databases in Azure. But it offers a SQL-based view over large volumes of data and is optimized for large-scale data warehousing. So I consider this a more of a high-performance relational database. Most of the time, I just use a regular MySQL or Azure SQL database, the managed instances, because the dedicated SQL pool, it's really pretty expensive as far as like the volume of data and the compute power it uses. You really only want to use this for like your like really big data that doesn't work that well within a regular SQL database. Like you have some super large data set and you need to process it very quickly within a relational database. So I would tend to go with the managed instances first, and then once you hit that limit, then this becomes a pretty good option for you if needed. But for the most part, you can even scale up. You can scale up the managed instances of those others to be pretty powerful too. So it does provide you another tool to be able to optimize for large scale data in a relational database. So it's the use case for this, or why you would use it, as a dedicated resource that's scalable and allows for complicated analytical workloads with predictable performance. So being able to manage large data and being able to quickly scale the database and have it be high performance for large data. And then if you're integrating it with a lot of other data sources, it can also become valuable. So I'm going to go ahead and play this video. This guy's got the finger guns. He's so excited about serverless versus dedicated. These guys do really good. These guys do a good job of this. So let me go ahead and figure out how to play this video. It's about a 7-minute video. And if I can't quickly find this link in here, I can go ahead and pull it did this in PowerPoint first. So I can go ahead and pull this link out. Give me just 1 minute while I do that. And this guy, he does it along with another guy. He's really like a popular, I don't know if I would call him a podcaster, but it's called like Guy in a Cube, which is like super like well-known like short videos on like how to use different technologies and why to use different technologies within like a Microsoft Azure Power BI environment. So I am still looking for this. Apologize for the wait. Trying to get the link out of this. Oh, I had to enable the content on this one. Okay, so I'm going to go ahead screen.
Yo!
And I'm going to put this in its own window. Copy video URL. Let's go ahead and do that. Right on sharing.
You just open a board, you choose the columns you need.
Everyone online here?
Yo!
Yep.
You can hear it? Okay. Yeah, this is Guy in the Cube. This guy's awesome. He's like super enthusiastic about Microsoft products. He does a pretty entertaining at the same time. They bring on a product guy to tell you more about it.
What's up? This is Patrick.
And I'm Brad.
And in this video, we're going to talk about the difference between dedicated and
This will really go
SQL pools.
into it.
Stay tuned.
And then talk about why you, like we said, as data engineers, having all these tools at your hand, it's good to know which tool is best for the
If you find us for the very first time, be sure to hit that subscribe button to stay up to date from all the videos from both Adam, this guy. All right, Brad, thank you so much for joining us on Guy in the Cube. Before we get started, why don't you do a quick introduction to tell the people who you are?
So I'm Brad Schacht. I'm a principal program manager on the Azure Synapse Analytics team. In my portion of the team, we are really focused on working with customers on a day-to-day basis and helping make sure that they are successful and bringing that feedback back into the product.
I'm sure Brad knows a lot of Synapse. That's all I'm gonna say. All right, so Brad, I'm an old SQL Server guy. I started tinkering with Synapse when it first came out. Then I went away and I started doing Power BI and didn't touch it. And probably about a year ago, I started getting back into it, and I discovered this thing called serverless. And I'm like, oh, this is nice, especially for Power BI, because I'm gonna cache up data. I'm not running queries very often. It just kind of worked out. And then someone would say, Patrick, you should really take a look at this dedicated. I'm like, why would I need dedicated? And so I reached out to you and I'm like, Brad, what's the difference? And then maybe I can make a better decision.
There's a lot of value in that serverless SQL pool. It's really great for doing data exploration, doing that logical data warehouse over top of the data lake, so you don't have to do a ton of data modeling. It really helps you get up and running with your data warehouse or your Power BI reporting in general. But sometimes you do need a little bit of extra horsepower. You need that really strict data model. You need those predictable SLAs. And so sometimes you do need to look at that dedicated SQL.
So you're telling me that I can use serverless though, if it fits the use case, right?
Absolutely,
Okay.
yeah. Tons of users, tons of my customers use it out there without even using the dedicated SQL pools at all. So nothing wrong with that.
All right, so enough of all this talking. You guys know how we like to do a Guy in the Cube. We're not hitting to my laptop. Let's hit to Brad's laptop.
So here we are inside of my Synapse Analytics workspace. And the really cool thing about serverless, all I have to know is that I'm sitting here inside my data lake right now, looking at a set of flat files. In this case, I've got my on-time performance data for my airlines. And all I have to do to query data, right click on it and say, select top 100 rows. And just like that, I can click a button and I can run a query. So I don't even have to know how to write T-SQL. I don't have to know all this other syntax. All I have to know is where my data is, and I can right click and run a query on top of it.
And I think this is great. This is so easy. If I write a process just to dump files into a folder, it could be a data lake, it could be all these other different places. I can just connect my Synapse to that storage account and then start querying it using serverless. And I don't need to do anything. I don't need to create tables. I don't need to move data into tables. I don't need to persist data anywhere. It just lives where it lives, and I query it when I need it. I can modify those queries. If I only want 4 columns from, let's say, the Parquet file, I can get those 4 columns. If I want 8 columns, I just go modify the query and pull in what I need. It just seems like the perfect place to do everything I want.
Yeah, it really does reduce that time to insight dramatically. And in fact, there's a lot more that you can even do with it with just a couple of little wildcards inside the URL there that I can show you if you want to take a look at it.
Yeah, let's take a look.
Here's that same query that we ran just a moment ago. You'll notice that on my query, I've got this data separated out by year, by month, and then I've got a set of files at that lowest level. But Patrick, I know we don't just want to look at October of 1987 when we're trying to figure out our, which flight we should be taking. But what we can do really easily is we can come over here, we can toss a couple of wildcards by just putting a star inside this file path. And what you'll notice now is I can actually use those wildcards in my query and say, you know what, let me look at all the data from 2019.
So just by introducing those wildcards, it'll traverse all the subfolders within that location in the storage account or in my data lake.
Whether it's one file or 10,000 files, all you have to do is put that wildcard, it'll pick everything up, piece it all together, and then allow you to query the data just as you normally would.
Nice. That's nice. I like it. And I don't have to worry about taking that data from those flat files, Parquet, CSV, whatever it is, and then moving it over to actual schemas. Now I'm locked into this schema. I have flexibility with serverless.
Yeah, absolutely. And you can do, as you mentioned, all those sort of analytical queries that you would normally want to do. If I wanted to come over here and take a look at all of my flights that came between a couple of cities for a particular airline on a set of dates. But if I wanted to start joining tables together inside of here, you've probably noticed this. It's not the most friendly syntax once you start having to come in here and like nest all these open row set things together.
Yeah, I think you're like some type of psychic or something, Brad. You're reading my mind because I'm looking at those queries and I've been writing SQL statements, and this is not scary to me. But for someone that's using Power BI, for example, or someone using Excel, this could be really, really scary for them. And they may go, you know what? I don't want to have anything to do with this. There's got to be a better way for them to access these serverless SQL.
Absolutely. And I can show you a great way to do that. If that open row set stuff is a little bit daunting for you, or maybe you just want to simplify things and do a logical data warehouse over top of your data lake, building views inside of serverless is a great way to do that. Specify the columns that I want inside my data set. I don't have to pull everything in from the files. I can do all my wildcards, so I make sure I pick up every piece of data all the way from 1987. And then I can wrap this into a view, and now all I have to do is query the view as though it's a table inside of my SQL server. So now, if you want to, you don't even have to stay here inside the web browser. You can head over to your favorite query tool, like Azure Data Studio. We can now query these tables, and they show up just as a list of views inside of my database.
Wow. So this makes it simple. Anyone consuming this, they could care less of what's on the back end. All they want to do is have easy access to the data. So if I create an object for them, and then they can just go against that object, this makes it easy. This is easy to consume. If they need to modify, they can send your request also to view, add more columns. So flexible, so easy. Now, I know that with serverless, it's a separation between compute and storage, and really complicated queries. Trying to do some analytics against this, things kind of slow down. You know how people that's consuming the C-levels, they don't want stuff slow. It needs to be as fast as possible. Is this where dedicated really shines?
Absolutely. Where serverless is going to be that data lake, querying over top of the data lake type of experience, the dedicated SQL pool is going to be a lot more of that traditional SQL route. So we actually run SQL Server underneath the covers of everything. It's going to be that more familiar create table type syntax. You're going to import the data into your dedicated pool. So there's a bit more work that goes into getting up and running. But like you said, it comes with the added benefit of ridiculous performance. Where we're spending time doing, 50, 60 seconds to do a query over there on the serverless side, yeah, it's easy to get up and running. But if you need that predictable, fast performance, set data types, everything really structured, then you're definitely going to want to go over to the dedicated SQL pool.
I know you're going to show us an example.
Of course I am. So if we take this query right here, this one is actually running on the serverless SQL pool. And as you can see down here in the bottom corner, the query took about 51 seconds to execute. Not too bad. Like I said, no data modeling, anything like that. But what I did was I loaded the exact same data set up into a dedicated SQL pool. And you can see at the bottom there, this one only took 6 seconds to run.
Wow.
So we're joining tables, we're doing aggregations inside the queries here. You can see just the power difference between the dedicated and the serverless SQL.
Now, it's like a SQL server, so it's on, you're paying for it, but there's something interesting about this. I can actually pause this thing.
You can.
Yeah.
So where serverless is that pay per query model, the dedicated pool, you're paying for it every second that it's up and running.
Mm-hmm.
So a lot of times I want to just refresh my Power BI report a couple of times a day. So my serverless, it doesn't matter if it takes 50 seconds to load my data model or if it takes 10 seconds. But I can go in and I can model the data inside of my dedicated pool. If I've got other queries that need to run throughout the day, I can let those run. And even if I only need to load it a couple of times a day, but I need that fast performance for some process, I can go in and I can pause this anytime I want to. You can even run a pipeline inside of your Synapse workspace or ADF to be able to pause that on a schedule.
Now, I would be remiss without showing a little Power BI here in this video, because I am just a sucker for it. I live it, I breathe it. And you showed me something earlier and it was really impressive. And I think we should wrap up to really show the true power of Dedicated by showing this demo that you put together. Is that okay?
Absolutely.
All right.
So here we are inside Power BI. I'm not you, Patrick. I don't have a beautiful report here, but what I do have is some data. You can see that this report is running off my serverless SQL pool in the background, and it's using those views that we were looking at just a minute ago. But the problem is, every time I make a change, you can see in the performance analyzer that it takes about 30 seconds to refresh all this data on the page.
So, Brett, this is direct query mode, right? You're in direct query.
Right. And so if you wanted to, of course, you could import the data. But in this case, let's assume that we need a direct query report. Just by coming up here, changing my data source, I'll switch this over from my serverless endpoint to my dedicated SQL pool. Again, same views, same schema, same data, apply my changes. So now that I've changed the connection and everything, let's see how fast this is. 3 seconds to load the entire report.
So there is a true difference between serverless and dedicated, and you need to pick and choose. You need to do a little research and look at your use cases, what are your SLAs and things like that, before you make a hard decision on which one that you're going to use. And even if you decide to start using serverless at first, you can use pipelines and things to persist that data to your dedicated SQL pool. All right, so what do you guys think? Question, are you using serverless dedicated? Brad and I would love to know. You know what to do. Post it in the comments below. It's your first time visiting the Guy in the Cube channel. Hit that subscribe button, like our video, big thumbs up. As always, from Adam,
Brad,
and myself, thanks for watching. We'll see you in the next video.
What do you get when you...
Right. So that guy's just awesome. And not only are his videos highly entertaining, but it's like really practical as far as like the questions that he asks, and dives deeper into Synapse technologies like Synapse Serverless versus dedicated SQL pool. So like he is saying, he does a lot of the Power BI videos, but they've been doing more and more of the Azure Synapse Serverless versus dedicated SQL pool. So personally, as a data engineer, that guy's he has a pretty good delivery, and it's not nearly as boring as most technical videos. But even as a data engineer, just the content itself and knowing like what you can do with just SQL skills now and how powerful it is within the Azure SQL Serverless environment, that Azure Synapse Analytics environment, that's like pretty exciting to me. Really. So if you feel your heart rate raise or a little bit, or are excited about that, you may have some data engineering. Yeah. All right. But that's an awesome video. I recommend all of I dropped the link in there because it's breaking up a little bit for Brenda, but I dropped the link so you can rewatch that I dropped it in Slack for everyone to be able to watch it. Right. So go back to the lecture. We'll take a break here shortly. We'll go ahead and get through the next slide, and then we'll come back from break and see Spark, and then dive a little more into APIs for data science workflows. But for now, we'll cover one more slide and then go to break. Share my second screen. Okay. So as much as anything, I just personally think this might be the most powerful portion of it. It's also why when we talk about ETL versus ELT is becoming popular, or ELT is becoming popular versus ETL, is because now with a data lake, instead of having to extract from systems and define all the transformations beforehand, you can just load all that data as is and then query the data lake or these data sources and then define all of your transformations later, thus the ELT versus ETL. And in some ways, that's quite a bit faster. Instead of having to define all of them up front and do that processing up front, you can really like discover and explore your data. And that's part of what they talked about. And then you could formalize it later in a dedicated SQL pool, or personally, one of my preferences is to formalize it in just a managed instance of Microsoft SQL Server database or MySQL database. But either way, you can define it all up front and do it quickly, and then explore it using like that SQL query language on almost anything in the data lake, and then put it in a data warehouse or formalize it later so you get more predictable performance. And then one more slide before we go. This is what it looks like. So an example of a serverless SQL data lake query. And this is how I did it in data lake. So I had to do a couple of things here behind the scenes. And if anybody would like to go through this, I can take you through how I did it. I had to do some security in the background to be able to execute this query. But in essence, what you can do is if you go to in Synapse Analytics, if you go to data, linked, and connect to external data, you can select the Azure Data Lake Storage Gen 2 connector. You can give it a name. You can use a subscription, and then the storage account name that you already have set up, and then publish changes. So actually very similar to creating a linked account and then data set like we have done in Azure Data Factory. So once you do that, you can then scroll to the data set inside of you can scroll to this data set that we have stored inside of our data lake. So inside of crypto data, we have that fact overview history CSV file. I was able to right click it and then just select top 100. And then when I did that, it produced these SQL-like results. So I'll actually show you, I'll walk you through that, what that looks like within Synapse Analytics. I'm going to go ahead and drag this over. Trying to take a shortcut into Synapse Analytics just by going to my PySpark pool. Hey, Stav, if you could bookmark it, that main page, just have it there so you can click it instead of having to go through the menu each time. And then I'll go back in here. So one of the things you notice is important when they talked about the open row set. That is how you'll open a file inside of the data lake. And then you can use that as a table within your SQL query. So think of this almost like a subquery where you're using this function open row set to open up this CSV file with these parameters, parts or version. So once I set up that link service, let's go ahead. The ODSA Data Lake JB. You have the crypto data folder. You have those 3 files in there. Then you can right click. And you see you can do a couple things. You can do a new data flow, integration data set. notebook, you could create a notebook and load it into data frame, or you can create a new script or table or bulk load it into database. Gives you a lot of options with the files here in the data lake. But we'll just go ahead and select top 100 rows. All other useful functions that you may find as a data engineer for a file in a data lake. But then it just automatically opens this code for you. And then you can hit run, and it gives you these results. And we should, within these options, be able to make this top row, the columns in the data set. I'd have to look at that. I'd have to remember what that parameter is, but that's the idea. All right. So I'll let everyone take a break. We'll take a 10-minute break, and if anyone would like to set this up, I'm willing to walk them through what I needed to do, the access that I needed to grant Synapse Analytics to be able to use the data lake. So if you want to be able to do this, query it in this way, I think that you'll probably have to do that. And I can help walk you. I'll walk you through setup during break, and then when we come back, we'll come back at 7:30. We'll also review at that time. We'll review the quiz results. So go ahead and hang tight, and drop a note to me if you'd like to try to set this up during break in the Cloud Engineering channel. But otherwise, go ahead and take your break. It's not required that we set it up or anything, but go ahead and take your break for 15 minutes, and we'll come back at 7:32 and review the quizzes. Review the week 2 quiz. All right. See you in a few. So I'll just drop everyone a note on what I had to do to get the data lake working with the Azure Synapse service. I'm scrolling there right now. This took me a little while to figure out today. But it comes down to access control. You have to go to role assignments. This is where you dive deeper into roles. And not only can users of the platform granted permissions, also the services and the apps are also granted permissions in Synapse Analytics. I knew this because I've set this up before, but it's actually I really had to think about it when I came to it. So what I needed to do was grant the Synapse Analytics service permission to be able to access my data lake. So I did this as a storage blob data contributor, I gave it that role. I looked that up on the internet to see what access it needed. I was able to I'll go back. So there's a lot in Azure even related to role-based access. Let's see. Let's go back here. Let's see. Clicked around a little too much. Access control. And what you can do here is add a role assignment. They have all sorts of different roles here in Azure. This might be a decent intro into the role-based access and access in Azure if you're interested in learning more. But well, what was the name of that role? It was a contributor, wasn't it? Storage account contributor. So it lets you manage storage accounts, access keys with full access to storage account. I know those guys, Patrick and Adam, are awesome. They're like a dynamic duo of Microsoft technologies. I mean, I don't listen like to dry, boring stuff all the time. That's like my life. Videos or reading and everything, but those guys do it not just in an entertaining way, but like an informative way too, like the way people think, I guess, or ask those questions on like why I should use this or whatever. Where'd you see him, Missy? Where'd you say?
I saw them at a Fabric.
You saw those
conference.
guys live?
Yeah. They're just as good live as they are on video.
I bet. All right, where was I? So storage account contributor, there are all the permissions. So I need to click next down here. So this is where I was adding that service into being a contributor on the data lake. So instead of user, group, or service principal, you get a managed identity. This is kind of why also I didn't cover too much of the role-based stuff itself, because all this role-based stuff is like almost its own. It's almost its own 4-week. You could almost do a 4-week class on it. I get it backwards like all the time. Is your Synapse Workspace, Manage Identity, Synapse Workspace. It's under that subscription, so you have to grant the Synapse. You have to grant the Synapse Workspace that resource access to your data lake. I've already done that, but you need to do that first, and then Synapse can use that serverless SQL pool. Then it's granted access into that data lake that you've created to be able to run that serverless SQL query to be able to read that data. It's banging my head for a little while today. I'm like, why wouldn't this thing just work? But then a couple Google searches later, and then realize you basically have to grant access to all people or every service to be able to sometimes or services to sometimes be able to interact with each other. I figured it out. Well, Missy, you probably almost had to Those guys are like celebrities almost if you're like into Microsoft and Power BI. You almost have to pay for tickets to their session.
Oh my gosh, it was
Like a
crazy.
show.
They were mobbed by like 100 people.
I know. It's hard to be a celebrity, I guess. I want to know.
They're very humble, despite how popular they are.
Yeah, there's some cool. Yeah. All right. I'm going to take a short break after that. That's if anybody goes back into the video and wants to know how to the role that needs to happen for Azure and the SQL Serverless Pool to reach into the data lake. Walk through it there. Otherwise, if you want to set it up yourself, I can help you do that sometime. So I'm going to take about a 5-minute break myself. I'll be right back. Grab some water. Doing okay. I'm hanging in there. I'll grab some water. Be right back. All right, 7:32. I'm going to settle in and pull up the quiz results here in a minute. Okay, I have them up. I think that we have all but one response. I think Ted is the only person who wasn't able to make it tonight. I think that's the only response that we are missing. But pretty good scores. I made this quiz, not as many trick questions, but I have to slip one or two in there to make sure everyone's paying attention. So questions 1, 8, and 9. I'll have to take a look at 9. I may have mislabeled that since somebody got the answer correct. But what is true about cloud storage? So let's see if we can go question by question so we can see these a little bit better. Question 1. So there are all the responses. So for question 1, check all that are true. All of them are actually true here. I had this from the class 3 lecture about cloud storage. So cloud storage is services where data is stored on servers in offsite locations. Instead of on-premises, you have some type of service provider, third party who's providing services on their premises. Whether it's private for just your organization or it's public, it can be either one. That combines those first two answers. Microsoft, Google, Microsoft, and Amazon are public cloud providers. This is true because they allow multiple companies on the same cloud platform. So that'd be like any one of these main service providers, like hundreds of companies are on their Azure platform. So it's considered public. To help data scientists implement cutting edge AI models. I don't know if I meant to have that one checked or not, but hot and cold are different storage options defined by accessibility and price. So hot and cold storage, the difference is hot is always available, cold is like not as frequently accessed, but the cheaper option. They're defined by accessibility and price. And apologize for question number 1, but it does help. The cloud storage also helps data scientists implement cutting edge AI models. That's true. All right. So question 2, the 4 types of data storage in Azure Data Platform are blob, file, queue, and tables. So I did throw Data Lake in there, which is a storage service, but it's a blob storage. So if we think fundamentally about the types of storage, the 4 main containers, it's file, queue, tables. File is more for like applications, and blob is what's considered the data lake is built upon. So a little bit tricky there. As far as when I said data lake, I knew I'd catch somebody with that. But data lake is a type of blob storage. It's fundamentally a blob storage with like additional features and ability to add folders and security and be integrated with Azure Data Lake. Okay. So what are the use cases for cloud-based data? Say all of the above. These were all ones that I talked about in lecture 4, whether it's log processing, real-time inventory management, being able to do things real-time, machine learning and artificial intelligence, obviously, and genomic data analysis, being able to take those huge strands of data and be able to analyze it. All right, so in your own words, what's the relationships between SQL and NoSQL databases? So NoSQL databases are really just like, well, starting with relational databases, these are structured SQL based and suitable for structured data with complex relationships. So no data, these are like, I consider these like the alternative non-relational databases that offer a different type of storage other than relational database tables. They're flexible and scalable for diverse data types in high volume distributed environments. Those are all true. Especially for data that's like JSON data or graph data or pair key values and so forth. They're more efficient, and they're more efficient as far as disk storage and processing also. So I just consider them, and they also tend to not use, they don't use the SQL programming language either. They tend to use their own programming language, or it's like some type of SQL variant language, because that's specifically designed for relational database, structured query language for structured relational databases. So what is a use case for Azure Streaming Analytics? So I just snuck one in here. It's was the Internet of Things data, the streaming data that comes off of all the sensors. Not so much for just big data itself. There are other technologies for that. And then watching YouTube videos, you could do that otherwise than streaming analytics. Big data specifically, I should say, that would be one that would be good for Spark, to be able to process a big data set in Spark and distribute it out over a bunch of nodes and be able to process it faster. All right. What open source technologies are included in HD Insight? So these were mostly all of the above, but I threw a trick one in here. This one is actually Kafka, and I threw Kerouac in there because he's like a writer like Kafka was, or a philosophical type guy. So I was just throwing one in there to see if I could throw anyone off. I don't know if I did or not. But Hadoop, Apache Spark, Kafka, HBase. So Hadoop for big data processing. Also, you can use it from HD Insight. I should say Azure Synapse Analytics HD Insight is also integrated with Azure Synapse Analytics. In your own words, what is the Azure Data Factory? I do like this first definition, just scrolling through it. So if you've been in BI for a long time, Microsoft had its own integration services that you could do ETL with. And Azure Data Factory is actually like a next generation of that in the cloud. It even still has services to migrate existing ETL processes. So ETL processes have been around for a while. Azure Data Factory really gives you like a new cloud-based service, all-in-one product, to be able to do the heavy lifting of data, the integrations, the extractions, transforms and loads, and mapping data. So just saying that in my own words, and then simply put, data integration and orchestration platform. But yes, I like these definitions are pretty good. I like those, especially comparing them to the old ETL, SSIS packages. And people still do a lot of those if you aren't doing ETL in the cloud. But it's like cloud is next generation. All right. Which of the following are NoSQL storage options within Microsoft Azure? I believe this was. I mixed a few in here, or I mixed them in here, and then mixed a few relational database storage options in there. And then GenLake 2 is really like blob storage, so I wouldn't call that a NoSQL. I don't think I would call that a NoSQL storage option. I'll double check that, since it's NoSQL is like the opposite of SQL. I know someone put it in there, but I think of this as a file store instead of like a NoSQL database. But anyway, then what the other check? Azure tables, I tossed that in there because we briefly covered that. That is also a NoSQL storage option where you can store data and query it. All right. So multiple choice. What are the different components used in Azure Data Factory? Pipelines, activities, data sets, mapping, and triggers. This was off of one of the slides in the data processing in lecture 4. I think maybe some of this might have thrown a couple people off, but because they're not really used to delete files, and then data quality and cataloging are done in Azure Purview. And then short answer, what is a data lake? Data lake is a centralized repository that allows you to store all of your structured and unstructured data at any scale. Flexible solution for storing and analyzing vast amounts of various sources. I think that's simply put, but well put also. There's more that you could do on top of it. It's like a blob storage. It's blob storage where you can have a file hierarchy and folders and add permissions to it and everything. So any variant of like a simple definition to larger definite or more in depth is acceptable on that one. So I scaled this down pretty well. I'm still a little bit behind on grading quizzes, so in providing feedback. So I'll try to get those done as soon as I can. And once I've done so, I can provide all the feedback, and then I release the quiz, and then you should get it. You should get it in the email address that you provided me. So I'll try to do that. I'll try to do that sooner than later. All right. So that's the quiz. If you have any questions before I provide feedback, let me know. Okay. So we have just a little more to go before our exercise. We have Apache Spark, and then we're going to start talking about why use APIs for data science workflows. We have another video here. It doesn't seem like I can play it after I upload these from doing them in PowerPoint to converting them over to Google Slides. That I lose that link in there. But I'll just talk about it briefly before we play this other video. It's another good introduction in how to use Spark. But some of the properties of benefits or best features of Synapse Apache Spark. I'll go ahead and do the whole slideshow here. So we have a managed Spark environment. Microsoft manages provisioning, scaling, and maintenance of Spark clusters. This is huge, so you don't have to manage the software and the hardware yourself. We talked about it in the NoSQL or the processing class, but one of the hard. It's difficult to manage and configure a Spark cluster, especially since it's distributed computing. Microsoft does a lot of that for you, which takes the pain out of that. There's language support, so Spark supports multiple programming languages, including Python, Scala, and Spark SQL. I haven't used Scala before. I think that's like related to data set specific language for like parallel processing. But of course, Python and Spark SQL are common languages you can use. Well, building collaboration, we talked about that as far as the notebooks, support co-authoring and version tracking, facilitating teamwork, especially between data scientists and data engineers. They're highly performance optimization. They're highly, the ability to optimize them is really high, and configure them is really high for performance. Spark pools in Azure are optimized for performance and utilize auto scaling, which automatically adjusts the amount of computational resources based on the workload. So Spark can actually recognize how much work your job is going to take within the Spark database, and then adjust its resources accordingly. SQL actually does something similar. It doesn't dynamically do it in SQL databases, but SQL databases generally have something that will also tell you how much processing your query is going to take. But Spark does it auto scales your resources automatically to match the workload, which is pretty cool. Direct data access, Spark pools can directly access Azure Data Lake storage and other data services. So you don't have to manage all your own data sources. You can just put it in Azure Data Lake, create Spark jobs for your transformations and other data sets. An ML tool integration. So Spark has its own libraries, ML Spark. I haven't used these because, like I said, I often just use a machine learning lab instead. But they do have their own libraries for building and deploying machine learning models. I'm sure they're really good and highly optimized use cases to use within the Spark computing environment. I'm certain that they have their use cases. I haven't dug into them myself, but the capability is there to be able to build the models there within the workbooks, and then be able to execute them all within Synapse Analytics. So I'm going to go ahead and pull the video out of my PowerPoint slide for this one. Going to we have another. It's my lucky day. We have a 2 guy in a cube videos. I forgot this was a guy in a cube video for a second, but it's given a little aloha there. It's also excited about Spark. Spark is really good for distributed computing. I use it sometimes on super large data sets, be able to break it into pieces and recompile and process it faster. So let's go ahead and put this in a tab. And then while I do that, I'll stop the screen. And then okay, that should be it. And then we'll go ahead and get started with this. I think the Power BI guy Microsoft realized that they were gold, and they just have them do everything related to Microsoft Azure now. So we'll go ahead and
What's up? This is Patrick.
This is Bank.
Everybody can hear it okay? I just make sure before.
In this video, we're going to introduce you to Synapse
I think
Spark.
everybody should be able to hear that, right? Okay, good.
Talk about all the different use cases. Stay tuned.
Okay, because we go through all the
If you find this for the very first time, be sure to hit that subscribe button to stay up to date from all the videos from both Adam and this guy. All right, Vane, thank you so much for taking the time out of your day. But before we get into this, why don't you tell us a little bit about yourself?
First of all, I wanted to say that you and Adam are doing a phenomenal job. I'm just honored to be here on your channel and talk about Spark. So I'm Venk. I'm part of the Synapse Customer Success Engineering team. My team actually works with our enterprise customers to deploy big data solutions on Synapse Spark and Azure HD Insights. So happy to be here and talk about Spark.
I actually went out and kicked the tires a little bit, but I wasn't sure about some settings and these notebooks and PySpark. So I decided, let's get somebody who really knows about this. So let's start by you telling us what actually is this Synapse Spark?
First of all, Apache Spark is one of the important tools within the Hadoop ecosystem. It's an open source big data analytics engine, so to speak, that allows you to do ETL, machine learning, data science type of workflow. It works on a distributed architecture. And Synapse Spark is specifically the Apache Spark operating within Synapse.
I think that's where I got stuck, Frank. I'm like, okay, I'm about to spin this up, but I have all these other options in Synapse. Why would I use Spark?
So when you talk about big data, you're talking about distributed architecture because that's the way to be able to process a lot of data. I mean, we're talking about terabytes to petabytes. That's where Spark comes into the picture. It's an in-memory engine on a distributed architecture where you can do your batch processing of your data, streaming, your data science, machine learning type of workload.
Large batches of big volumes of data. All right, that's interesting. So since you're here, you guys know how we like to do a guy in the cube. Instead of all this talking, let's head over to Vank's laptop.
Sounds good. Let's do that. Before we talk about Spark, obviously I'll go to my Synapse workspace, open my Synapse Studio. Before you write a single piece of PySpark or any code you want to write, go ahead and create an Apache Spark pool. Apache Spark pool is basically the engine against which you're going to submit your queries. It's very similar to like writing SQL queries against a SQL server. On the left-hand side, we're going to have the manage bar, and then I've got Apache Spark pools, and then I'm going to go ahead and click plus Neo. Creating a Spark pool is as simple as few steps where you give it a name, pick my node size. The node family is right now you only have memory optimized. There's some future options that's going to be available. Then you have the node size, then you have auto scale. And it's as simple as just setting these basic properties and just go ahead and click review and create. For the purposes of the demo, just like a cooking show, I have an existing cluster that I already configured. So we're going to switch over to that.
So when I went to go and create my Spark pool, the first place I got stuck is what size do I choose? Because there was a list of them. I was like, should I start small? Should I go big? I wasn't sure.
It really comes down to the data volumes, the complexity of the process that you're trying to run. If you're doing demos and stuff, you can start off with a small configuration. It really comes down to, hey, the number of cores and the amount of memory you want on each of your individual nodes. More data and more complexity, go with a bigger node size.
All right. And then, right, I saw that auto scale and I was excited about this auto scale, but then I was like, okay, I have this lower and this upper bound. What do I set?
I mean, auto scale is just a way for Spark to kind of scale up the number of nodes on your cluster based on resource requirements like CPU and available memory. Upper bound is a way for you to govern your costs for your work. Lower bound is really, hey, what is the starting point? You don't want that lower bound to be too low where your jobs are suffering.
So if I have a fixed workload, I probably don't need auto scale. But if I have a variable, let's say it's a cyclical type of thing where, I need more compute during this period of time, maybe I enable auto scale.
Depends on the data volumes that are coming in. Sure. Yeah.
All right. So that's great. So now what do we do with these Spark clusters once they're ready to go?
The next thing we're going to do is we'll go ahead and create a notebook. The way you do that is in your Synapse Studio, on the left-hand side ribbon, there's an option for develop. And then we're going to go and click this plus sign to go create a notebook. And the first thing I do after I create the notebook is to go and attach it to a Spark pool. So in this case, I already have a Spark pool configured. So I'll go ahead and pick that. And now we're going to start writing some Spark code. For the demo today, we actually going to leverage Azure open data sets, some public data sets that are available on Azure. In this case, I'm using a small data set called public holiday. Here, what I'm doing right now is just providing some connection information like, hey, where is my storage account? What is my storage account name, app, and so on and so forth. I'm not actually doing anything. I'm differentiate my Spark application to establish a connection to the Azure Blob Store, or in this case, where my data is sitting. It's like when you're trying to connect to a SQL Server or your SQL pools, you have the server name and credentials and so on and so forth, and that's what we're doing here. Next step is we're going to actually go ahead and create a data frame. So in this case, we're actually going to make a reference to that public data set. In this case, the public holidays data. Data frame is just an in-memory table. I'm using a function here called spark.read.parquet because the data is in the Parquet format. If it was a CSV file, you would just use a function like spark.read.csv. Next thing I'm going to do is look at the sample data set. Look at the top 5 records, straightforward. Also, look at the schema. Relatively small data set, 4 or 5 columns. That's as simple as writing some Spark code by pulling your data sitting in DLS storage.
Okay, thank you. Showed us how to create our Spark Plus. Super excited. I know what size. I know when to enable auto scale. But now, where am I going to go next with my Spark cluster?
With a modern big data analytics platform, when you have to process a lot of the data, you actually bring the power of Spark to Synapse. And it's really for your data engineering type of workflows where you're trying to do ETL, applying business logic, doing your transformations at scale to actually produce data sets that are ready for you to be consumed for your reporting tools and so on and so forth.
All right, Bank. Thank you so much for joining us. So guys, if you have any questions, comments about Spark, when to use it, you know what to do. Post it in the comments below. If it's your first time visiting the Guy in the Cube channel, hit that subscribe button. If you like my video, give me a big thumbs up. As always, from Adam,
Bank,
and myself, thanks for watching. We'll see you in the next video.
I can hardly wait for their next video. I think I'd probably just watch it on any topic. But that's really the use case for Spark is the distributed computing piece, and when the processing of a huge data set gets so big that you need like distributed computing or a bigger resource for that, which occasionally it can happen with data sets that are millions of records or have a huge number of columns, or maybe it's huge JSON or log data or real-time data that you need to parse through. That's the use case for it. I didn't ask this group, did you use, when you took your Python class, did you use pandas and data frames in pandas?
Yes.
You did? Okay. So Spark data frames are almost exactly the same as that. You can view them you can load data into data frame in Spark and then view them in a similar print and view them in a similar way and access columns. However, the Spark data frames are especially designed for the Spark processing and ecosystem to be distributed and everything. That's the only real difference, and then just a little bit of syntax difference. You won't use the same functions as you did. Pandas is a little more dynamic in the things that you can do, whereas Spark's, you can do some transformations of data with it, and the functions are different, but really meant to break it out, that data set out, and then bring it back together. So I'm going to go ahead and show everyone an example. Go ahead and share my screen. And I actually ran out of time to get this to work today. So I was able to do the code in the same way that we did it for the serverless SQL query. You can right click on the data set and then it'll generate this. If you go to create the Python PySpark notebook, it'll create this for you. So it starts with the 2% signs in PySpark and tries to read that data file into a data frame, and then it does the first 10. The problem with mine is that my workspace limits me to a number of cores, and the automatic, it was calculating that it needed more cores than that. And then the only way to be able to get more cores is to go through Azure support and have them raise it for my account. which I could do, but I wasn't able to get that done today. So it may be different for somebody else if you set up a Spark cluster. So I set up a Spark cluster and said ODSA Spark JB. And maybe somebody else will be able to run this, but I wasn't able to because of that limitation. But ideally, what you can do is run this. You could right-click that. You can load the new note or do a new notebook and load that data set to data frame and then run everything. And it would give you your top 10 results in the data frame. So there's a lot of configuration to do in Spark, and then choosing like what the right computing resources is and everything, and you see, but that also gives you some flexibility and be able to dynamically scale up to date and down to data sets if you need it. So that's the biggest advantage of Spark. And through the rest of the class, I won't need you to use the Spark cluster itself, but if you want to configure it and go through it, I'm happy to help you do that. All right. So we'll go through this. We have a couple of slides here, and then we'll get to our exercise for tonight. So why use APIs for data science workflows? So we're going into this new section talking about why you would use APIs for their data services and be able to integrate these. What are the advantages of those, of doing that? So APIs enhance data accessibility, quality, and automate data integration processes for model development. So they make it more accessible. So you can write, like an easy request to a REST API, or even if you think about your API libraries in Python, it's easier access to data or some data service or database. It improves data quality and automates the data integration process, particularly over if you have to do manual collection of all this data, or it's some laborsome task to gather it and transform it and everything. APIs provide a standard way for you to go get your data so you don't have to worry about that. So why are they crucial? They provide direct governed access to data, such as databases, web service, and enterprise systems. So just what I was saying is like, it's a data source that's already set. It's usually like clean, the data quality is good. It's the way that they want you to see it from the system, so it's governed. And then it provides that interface with databases and web services and systems. So you aren't creating a whole bunch of versions of the data and not knowing which one's true. You just get it from the API. They also provide real-time analytics. So some of the different types of APIs will allow data scientists to deploy models. They'll provide data, real-time data for data scientists who deploy models where they need real-time data. So if you think of like Internet of Things and like Tesla vehicles needing to be able to see things in real time, a real-time service would be able to grab that data and feed into the models that the data scientists create and provide insights and actions without delay. So in basically real time, you can do decision making with machine learning or AI models because you're constantly feeding it real-time data. So one of the other applications of this is fraud detection. So like if millions of transactions are coming in on your credit cards, they're able to get the newest data right away and be able to detect fraudulent activity on your credit card. Like pretty close, like as close to immediately as you could. I recently had a credit card I lost, and within like 3 transactions in like 15 minutes, they already knew it was fraud, which is crazy because of the spending pattern and being able to get that data in real time. They were able to shut that off and keep somebody from charging much more money on the credit card. And then model deployment and management. So this is the reverse side of it. When you deploy a machine learning or AI model, you can wrap it in an API or REST API, either a programmatic API or some type of REST API. where it can be accessed by other systems or programs and simplifies the management of the model. So we'll do that in this class as part of our project, is deploy it as a REST, the model as a REST API. And then we could use that API. We can just call the API and get the most recent data, or feed it some data, some parameters to be able to get the results that we want. So it makes model management
Hey, Jeremy.
and be able to integrate it into other systems. Yes.
The tornado alarms are going off here in West Omaha.
Are they?
Yeah.
Okay.
So you must be under a warning.
I was worried about that since we were under tornado watch. Should we? I have 2 more slides and a video. I don't want to make anybody unsafe here. I don't know what we want to do as a class, though. Should we keep going until I'm in East Omaha?
Yeah, I'm okay with that. I just want to let you know that, that I'm going to be paying attention to that too, though.
Yeah. We may cut it. I mean, I'll try to go through these last slides, and we may cut it off early, especially if they're like tornado warnings and sirens going off for everyone. That's
I hear him in Papillion too.
You hear him in Papillion. So I'm going to do the last 2 slides, and I may just I thought about recording the exercise myself anyway. I may call it good for the night and then record the exercise for everyone. Does that sound okay?
Yeah.
Okay.
Yeah.
Yeah, I'll try to get through the last 2 slides here, and then we'll take cover, and then I'll record the exercise, and then we need to give ourselves some time to work on all this stuff, I think, too. So be safe, everyone who needs to drop. I'm going to get through these last 2 slides quick. I'm going to save this. I'll record the exercise for tomorrow. I have homework 2 now. I gave everybody that link. That's just from last week, the exercises from last week. And then I'll catch everybody up on what we're doing here. And the guided video might help with that. So be safe, everyone who has to drop. And by all means, take your safety first while we go through this, or while I cover the rest of this real quick. All right, I'm going to go through this really pretty quick. So data science workflows. This was a pretty good, just a comment on this graphic. It's really a pretty good indication of how you ingest REST APIs, loading it into the data lake, doing the cleaning and the exploration of it, modeling it via Spark or SQL Server Pool. And then it's really a continuous feedback loop here. So thinking about writing in the rule, creating the rules, what levers do you pull, monitoring it with the dashboard and app, and then continuing to feed data into the model to improve data and continuing to monitor. So I had another arrow drawn right here because it's a continuous feedback loop, but REST APIs also help with continuously getting new data for your AI and machine learning models and updating them and being able to act on the newest information. All right. So benefits of automating data collection using APIs and data pipelines is all of the above. This is a quick summary. So efficient data retrieval, APIs facilitate seamless access to diverse data sources, streamlining the retrieval process. We talked about data or REST API ecosystems. This is part of that. It provides really easy standardized access to all of that. It automates data processing, eliminates the manual collection and transformation needed of data, which increases the efficiency and accuracy of the processing data. That's what I mentioned in the first slide. Enhanced data quality. So automated processes, they really tend to reduce manual errors, whether you think of like manufacturing and using robots and things like that. They tend to reduce the manual errors that people will make when they oversee data, especially lots of data. that improves the overall quality and reliability and scalability and flexibility. So APIs and data pipelines enable scalable and adaptable data collection and processing capabilities. So you can create an API. If you're managing the API, you can scale it up as needed or create real time to be able to meet your evolving needs. Especially like if you create a machine learning model, you're able to scale that up to meet whatever application that you're then interfacing your model with. Okay. So I have one more video here. This was a walkthrough of using Synapse Azure Data Factory, the pipelines for the REST API connector. We'll call it good for the night after this because this will really give you a good introduction into what the exercise is going to be. So this is exactly what it'll end up being. Is taking the copy data activity in this is Azure Data Factory, but we'll do it in Synapse Analytics, connecting to a REST API and loading it into Azure SQL database. So I'm going to play that and probably call it good for everyone because so that you're safe from the tornadoes and the tornado warnings. And then I'll record our specific one tomorrow. So this leads into the exercise that we're going to do. So I'm going to go ahead and play that video and then let everyone take cover if needed. Or if you have a siren or to be safe or however you would like to do that.
Hi all, welcome to the shop.
So I'll put this in my web browser and feel free to drop if you need. I haven't heard sirens yet, and I live in Northeast Omaha, but I'm certain that they're coming. So I'm going to share this screen. I'm pretty confident this works now that I'm sharing this tab and think everybody can hear it.
Hi all, welcome to the channel Cloud Knowledge. Today in this video,
It's
we'll
about
study
11.
about
If you
copying data
need
from
to be over
REST
Portland,
API
feel
to
free.
Azure SQL database. Okay, so let me first show you here in the whiteboard that our source and target would be here. The target is Azure SQL DB, where in a table, let's say T1, we will land the data and the source will be REST API. There'll be an API, there'll be an URL, and from the URL, we'll have, let's say, users data present, user 1, 2, 3, and so on, and the relevant details, let's say ID, name, something. Okay, these details we want to copy into the database, okay, in the form of a table. So ID column should come from this REST API, then the name, then other details, okay, which is present in the form of document valid JSON here at the REST API URL. So these all information we want to copy to the database. So how we will accomplish this in ADF, Data Factory. This is what we are going to learn in this video. So let's go to the Data Factory. Here we are in the Data Factory. We'll create a new pipeline. Let's name this pipeline as copy REST API data to SQL DB. Okay. Here, then next is we'll take the activity in the canvas. The activity for this purpose of copying the data from the REST API to the database would be copy data activity. So it comes under the move and transform section with the name as copy data. So we'll take the copy data in the canvas. Okay. Now in the copy data activity, we'll leave the general tab as is. Okay. We won't do any change here. we'll go directly to the source tab. And now we have to connect to the source data set. In our case, the source data set is this REST API URL, right? And in ADF, in order to connect to the REST API URL, we have the link service known as REST API. But before going to create link service, we'll go first to the REST API URL. So here, if we go in the first tab of the browser, I have this users related REST API URL. Okay, this is the URL. Okay, you can see at the top. And from this URL, we can see that it has the user's data present. Okay, ID, name, username, email, address, phone, etc. These details, ID 1, 2 till 10. Okay, we want this data to be loaded into Azure SQL DB through Azure Data Factory. So we'll go back to the data factory and connect to the source dataset. But before connecting to the source dataset, we have to create the link service. Okay. So here in the source dataset, we'll click on plus new, and in the new dataset, we'll search for REST for the REST API. We'll click on REST and then click on continue. We'll name it as users API. And next comes the setting of link service. We'll click on it. And since the link service is not there for this REST API, we'll click on plus new here. The first option present under the drop down of the link service. We'll click on plus new. Upon clicking, it will open up the configuration setting of the new link service. So we'll write this REST service for users, data, description, connection, integration runtime, and the base URL it is asking now. So the base URL will be this URL. So copy the URL and paste it here. Authentication will give it as anonymous. Okay. Then rest of the settings as is. We'll click on now on the lower right side test connection. So the connection is successful. We'll click on create. Okay. So this REST service user data will be created. So the REST service users data link service is selected here for the source data set. We'll click on OK. Right. Once the source data set is selected, other options also appear in the source of the copy data activity. But we need not change any of these options. We'll leave it as is. Okay. Now, next is we'll go to the sync. We'll go to the sync and connect to the sync dataset. For the sync dataset, we have to connect to the SQL database, right? For the SQL database, we already have the link service in place. So we'll make use of that link service. So let's search for SQL database, and it is Azure SQL database. We'll select that, click on continue. We'll write it as Azure SQL REST API destination. The link service is Azure SQL Database CK SQL DB. We want to land it into CK SQL DB, and the table name we have to give. Okay. So we'll select none and we'll click OK. Now here at the sync level, we have to do some settings. Like we have the table option. So here we have auto create table. It automatically creates the table if non-existent. So we'll click on auto create table. Okay. And we can use this pre-copy script if needed. Okay. For now, we'll leave it as is. Now we'll go to the sync dataset and try to open this dataset. Okay. If we try to open this, we can see that the table is not selected. Okay. It is not even none. So if we go to this pipeline, if we click on validate, it will show us error. The table is required in the copy activity. That's why we have opened the dataset. And here we will click on edit and give the name of the table. So we want to land the table inside the DBO schema into the table, which is named as target REST API users data. Okay. Target REST API users data is the table name. We'll go back to the pipeline and we'll try to validate. Now it's validated. Okay. So the source and the sync setting is done. Now the most important setting is the mappings tab. Okay. In the mappings tab, we will try to import the schemas as well as enable the advanced editor option. Okay. So if we click on import schemas, it has now shown upon importing schema, it will show us the incoming schema and the output.
So I want to pause real quick because this was an awesome feature. It actually took that JSON file from the response of the REST API request and it just unpacked it, even email address, street, suite, city, and so forth, and then mapped it straight to that database table. That saves a ton of code having to parse through the JSON file to be able to get all of the elements that you need. So this is odd. This is why at the beginning of class I was saying, wait for writing Python code for to parse JSON responses because Azure, either Data Factory or the Synapse Analytics pipelines do this for you also. Just had to take a quick time out for that.
Good schema. Okay,
Make
it is showing us, right?
Good point.
And if we click on advanced editor, it will show us the hierarchy. ID, name, username, email, address. Address has street, address has suite, address city, address zip code. The hierarchy also is showing here. Okay, so we can here manually do the mapping too. Okay, so for example, address street is there. So here we can write address underscore street. Then here we'll write address underscore suite. Address underscore city. Address underscore zip code. Okay. Other settings are also there for the latitude. So address, let's add here to address, longitude, latitude, then phone, website, no hierarchy, then company, let's not change it. So we have given the destination names as per our requirement. Okay, this is done. So whenever we are going to copy a document from the REST API, so whenever we are going to copy the data, we have to do the mapping here. And we have the feasibility of this advanced editor and import schema option, which will enable us to do proper mapping. Okay, let's now validate this pipeline and try to perform a debug run. Let's click on debug. And here we could see that the copy data activity is queued. We'll click on refresh. It's in progress. In the meantime, we'll publish the changes, publish all the changes. Publishing is in progress. And the debug run is also executing. So the debug run completed or succeeded, right? We can see here the input. Okay, whatever was the input and the output. Okay, the data read and the data copied. So let's see if the data is properly copied or not into the target. So the target was, let's open this. The name was target REST API users data. Let's copy this name. Go to the SQL database, CK-SQL DB. Here we have, we'll refresh and here we'll write the query, select star from, the table was inside DBO. Okay, DBO schema, will click on run and here we could see the data, ID, name, username, email, address underscore street, the column name, which we renamed, address suite, address city, zip code, lat, long, phone, website, company name, catchphrase, and BS. All data has been copied to the SQL database table using copy data activity of Azure Data Factory. So this was a very simple example on how we can copy the data to the SQL database from the REST API URL. I hope you've understood the video. Do let me know in comments if you have any queries. Thank you for watching the video. Happy learning. Bye. Hi all.
Sorry. Say I was on mute there. I started talking, but this video, I'll let everybody go here in a minute, but this video is a perfect example of what we are going to do here for the exercise of homework 3. It's taking a REST API. It maps the data factory pipeline, maps the data into a SQL database. It's what we're going to do with the crypto data. So those CSV files are actually from REST API endpoints from the REST API endpoints from this crypto data website. So I could show you that. Share this entire screen. I have not hit the tornado warning yet, so if everybody else needs to go, feel free. But it's this live CoinWatch website, and I have a couple of different endpoints for this. And the exercise is going to be to go through the overview history website, use the query in Azure, set up the endpoint request in Azure Data Factory, and load it into the tables that we already created using those CSV files. So the CSV files came from this REST endpoint. I just put them into CSV files for the initial load, and then we're using the REST APIs to automate the process. So if this seems like a lot, it probably is, but I'll provide a video tomorrow with the connections to those REST APIs in Postman, and then I'll walk through an example of utilizing those REST API endpoints to be able to fill in the tables in MySQL database. So what I would recommend is I finally put out a formal copy of homework 2. I would try to take the rest of those CSV files. I take those CSV files, use Azure Data Factory, and load those CSV files into MySQL tables. Because once you have those MySQL tables, then we can connect this REST API to those MySQL tables. And if you have questions on homework 1 or need caught up, it might be a good time for a working session to set up with everyone or one of these classes. I'm thinking of one of the classes, instead of doing the big data lecture, I just set up a working session on all of this in the project work. So I'm considering that too. If anybody's in favor of that, just taking a step back for a few hours and working on what we've already learned, I'd be willing to do that. And then create a big data lecture for the very last class after the final. I think that's what I'm going to do. So we'll have a regular lecture over machine learning on Wednesday. Then we'll do like a full project and working session and catch up on all the homework next Monday.
Thank you. That would help.
I think so. We're covering a lot. There's a lot to cover here, and don't want to leave anybody behind. Want to make sure everybody gains all the skills instead of just trying to pack a bunch of information into the end of this class. I think just one class where we all worked on the project and the homeworks and worked together would be good. So I'm going to switch up the syllabus a little bit and I have one big data lecture at the end for those technologies we didn't really cover, but I'll just make that like a very last class, going over it like future trends and big data and stuff like that without having to worry about any exercises to go along with it. Might not even lecture on it. It might just be a reading for everybody. That seems like it just taking a step back. This is like, it's a lot of technical and it's easy to run into problems with Azure. So I think that'd be a I vote for it myself. Just knowing how much we covered and even covered a lot today. So taking a step back and working through everything as a group would be good, I think. So I'll go ahead and do that. I'll record this demo. I'll do that tomorrow. Record the demo of connecting to the REST API and loading that into my SQL table. And then we'll have close to all the components that we need for the final project, other than the lecture that we'll do on Wednesday, the machine learning lab lecture that we'll do on Wednesday. All right. I think that settles it and it'll be good. Be safe, everyone. Look for those tomorrow. I need to catch up on grading quizzes and homeworks too, so I'll try to do all that as soon as I can. Thanks for everyone's patience. I'm actually feeling better the longer I go through this lecture, so pep me up a little bit or got me going again. So I appreciate the class's patience and working with me. All right, everyone, be safe and talk to you later.
Thank
Look
you.
forward
Everyone.
to coming soon. Yep.
Have a good
Bye.
night.
Have a good night. Bye.